Welcome to this video on steam engines and Hardz, tracing their journey from mine pumps to tourism. We will explore the history, technology, and heritage of these magnificent machines. This video examines steam engines and Hardz, focusing on their evolution from vital mining equipment to a key component of tourism, encompassing their history, technology, and cultural significance. A steam engine is a traction vehicle powered by water. Steam, generated in a boiler by burning coal, converts thermal energy into mechanical movement for the driving wheels. Key components include the boiler, firebox, steam cylinders, crankshaft mechanism, and driving wheels. Steam engines were historically used for transporting people and goods on public and industrial railways. Mining faced a major challenge in the 17th and 18th centuries due to groundwater flooding and the lack of effective deep water removal methods. Thomas Newcomen's steam-powered pump, introduced in 1712, was the solution. It utilized steam to drive a piston. Operating the pump, mining and coal were central to the steam age. James Watt, a Scottish engineer and inventor, significantly advanced the steam engine. His improvements, including the centrifugal governor, ensured the safe and stable use of steam. The governor automatically regulated engine speed, preventing rotational changes without human intervention. Higher speeds caused the connected balls to move away from the axis, regulating the steam valve. George Stephenson's rocket, built in 1829, was a pioneer in railway history. It was designed for the Rainhill trials on the Liverpool-Manchester Railway. The goal of the competition was to find the best steam engine for practical operation. Rocket featured several technical innovations, including a multi-tube boiler for increased heating surface and a blast pipe for improved draft and combustion efficiency. The direct drive transmission to the wheels also minimized energy losses. These features became the standard for later steam locomotives. The rocket achieved a maximum speed of about 45 to 50 kilometers per hour, weighed around 4.3 tons, and used coal as fuel with a 022 axle arrangement. For the 1820s, these performance figures were revolutionary. The rocket was the winner of the Rainhill trials and established a design template for steam railways. It proved that steam railways were both efficient and profitable. The rocket marked the beginning of modern rail transport. Coal formed millions of years ago from plant remains in swamps and ancient forests through pressure and heat processes. The transformation stages are peat, lignite, and hard coal. The calorific value increases with depth and age. Coal became the primary fuel for steam engines and industry. In the 18th and 19th centuries, mining evolved from manual quarrying in underground mines to using mechanical hammers and steam pumps for dewatering. Early mining railroads also emerged for coal transport. This development resulted in greater availability and lower cost of raw materials. Coal processing involved sorting by quality and calorific value, drying, and sometimes pre-coking to produce coke. Coke was a crucial fuel for metallurgy and heavy industry. Locomotives and industrial machines required high-quality coal with a high calorific value. Comparing the calorific value, lignite is about 12 to 20 megajoules per kilogram, hard coal 24 to 30 megajoules per kilogram, and oil approximately 42 to 46 megajoules per kilogram. Despite its lower calorific value compared to oil, coal was cheaper and more readily available in the 19th century. Major coal mining centers in the 19th century included Great Britain, Germany, the USA, France, and Belgium. Specifically, areas like Lancashire, Yorkshire, and Durham in Britain, the Ruhr Valley, Saxony, and Rhineland in Germany, Appalachia in the US, and Charleroi and Nord-Pas-de-Calais supplied the steam railway and factory industries. Coal was the ideal fuel for steam engines due to its high calorific value, which produced powerful steam. It was also easy to transport and store at stations and in wagons, and readily available across Europe and America in the 19th century. Without coal, steam engines could not have operated effectively. Steam engines enabled the rapid transport of coal from mines to cities and factories. This led to the creation of the first railway lines dedicated solely to coal transportation. Steam engines provided a stable energy source for factories and facilitated trade and urbanization through railways. The combination of coal, steam, and movement drove modern industry. Historically, examples include Lancashire and Manchester in Great Britain and the Ruhr Valley in Germany. Hardz steam engines transported coal to foundries and factories. The Hardz region features difficult terrain with steep slopes and narrow valleys. Sharp turns and limited space presented a challenge for laying railway tracks. The construction of lines and the adaptation of steam engines to the mountainous topography was a significant undertaking. Technical adaptations for steam engines included narrow-gauge railways, reinforced boilers and brakes, and special wheels or rack systems. The rack system, like the ABT system, improved traction on inclines, ensuring safety and stability during transport. The Harz narrow-gauge railways network spans over 140 kilometers, operating from the 19th century to the present day. These steam engines serve both freight and tourist transportation. The Harzer Schmalspurbahnen is a living museum of railway transport. The Harz region is located in central Germany, covering parts of Saxony-Anhalt, Lower Saxony, and Thuringia. It is the highest mountain range in northern Germany, with the Brocken being the highest peak. The region is known for its dense forests, deep valleys, and historical mining. The Harz has a long history of mining, especially for copper, silver, and iron, with the largest mining center being Clausthal-Zellerfeld. The region was a significant supplier of raw materials for German industry. The construction of railways was essential for transporting resources from the mountains to the plains. The Harz narrow-gauge railways were initially built to transport ore and wood. Construction began in 1887. The narrow gauge allowed for better adaptation to the challenging topography and reduced construction costs compared to standard gauge lines. The Harz narrow gauge railways include 25 steam engines, both operating and non-operating, and various diesel locomotives, electric trains, and railcars. The oldest locomotive still in use is the Mallet steam engine, dating from 1897. The narrow gauge of 1,000 millimeters is still maintained today. The Harz narrow gauge railways are one of the last steam railway networks in Europe, still in continuous use. It is a major tourist attraction, transporting approximately 1.1 million passengers annually, many of whom are steam engine enthusiasts. The preservation of the Harz narrow gauge railways has been a continuous effort since the 1990s. They are maintained by a dedicated team, with ongoing conservation and technical modernization to ensure the network's future. The Harz narrow gauge railways represent a living legacy of the Industrial Revolution, demonstrating the ingenuity of 19th century engineering in challenging mountain environments. It is a monument to steam transportation and a significant part of the Harz cultural heritage.